welcome to this first session of the second day. How do you like the conference so far? Yeah, a little bit more, come on. Get up. So welcome to this talk about microfrontends, a strive for fully verticalized systems. Who has ever heard about the term microfrontends? Okay. Who ever used it in production? Okay, and who regrets to use it in production? Okay, so I would love to ask this question again in 1 or 2 years. Let's see how it will turn out. So first things first, my name is David Leitner. I'm working as a principal engineer for a company, a very small company actually from Vienna, which is called Square Solutions. I tended to work many years for German consultancies, so actually I'm not so familiar with the IT in Vienna, I would say, because I worked for the most time of my life for German companies, but now I'm back in Vienna. Actually, now I'm back in Prague. So that's about me. I'm here for the rest of the day, so if you have any questions, feel free to reach out for me. Otherwise, there's of course also my Twitter handle, and you can send me messages there without actually even following me, yeah? That's totally fine. So, I would have loved to start this presentation with a classical definition what a microfrontend is, right? So you know a classical Wikipedia thing where you can read, okay, this is it, cool. But as often, or actually I would even say as usual in software engineering, we do not have a common understanding what we are talking about, right? So I often have the feeling when I talk to people about microfrontends, we talk about total different things, and that's fine. I'm not religious about the term itself. I think it's just important to understand that we do not have a common understanding yet what a microfront actually is, right? But at least there's one definition I like. It's the one from Michael Gears. He says the idea of microfrontends is to extend the concept of microservices to the front-end world. And this sounds super simple, right? Just take all the advantages from the backend, move them to the front-end, and we're done, right? This is a love story, right? But everybody who is working for more than 24 hours in software engineering usually knows that this is not working most of the time, right? We cannot just steal concepts from one side, put it on the other side, and hope that it will work, yeah? So let's take a step maybe back, and let's try to find a way to describe why we actually do these things usually. So if I work for clients, or if I go to clients, this is usually the blueprint architecture, the standard architecture I see these days, right? So we have a couple of microservices. We have some kind of single-page application in front of them, Angular, Vue.js, React, whatever you prefer, yeah? And in between, we have a gateway, right? So this is, I would say, 80% of the projects I come to look currently like this, yeah? And I'm in the mood of telling you secrets today. So the first secret I will tell you today is that this is fine in 80% of the cases, right? So in 80% of the cases, what you will hear today, you will not need it, right? Just a short disclaimer, because I don't want you to come back on Monday to work and say, hey, I heard this great talk about microfrontends from this great guy, right? We should do microfrontends now. No, in 80% of the cases, this is totally fine, right? You will not need microfrontends. And I'll tell you a second secret. As I said, I'm in the mood of telling you secrets. In 80%, even this would be fine, right? But I'm not here to blame microservices today, not today, yeah? So let's assume we are building microservices because we really need the benefits from them, right? And in comparison, well, not actually in comparison, we want to have those benefits. And actually, why do we want to have those benefits, right? Why do we build microservices? Actually, because we want to be autonomous. What? That's the one and only reason Sam Newman brought up in his great book, Building Microservices. We build microservices to be small and focused on one thing because we want to be autonomous, right? That's the definition of microservices. So even the definition of microservices is micro. So why do we want to be autonomous? Well, that's the obvious point, is we want to deploy independently, right? That's why we mainly often do this. That's the number one point when I talk to people, why do we actually do microservices? They usually know this one, right? Of course, we want to have distinct operations. We want our services to run on their own. We want to have our services to stop on their own. We want to have our services to restart on their own, to have persistence on their own, to really be fully autonomous in how they run, right? Another point is that we can be technology agnostic. I always put the pressure here on can, yeah? I mean, we don't have to, but in general it's a good thing that we can solve issues with frameworks and tools which fit our problem best, right? So this is what microservices allowed us to do, to really build platforms in technology agnostic ways. Another reason is that we have small interface surfaces. So in a microservice architecture, you have a clear definition of your boundaries of your system. So usually we expose a quite limited number of APIs from our microservices, and so we ensure that we have a small dependency between those services. Another one is, of course, modeling around business domains. I will not go into this whole Blue Book DDD stuff in detail. It's just not enough time, but of course that's one of the big advantages, that we can start to model our microservices, our teams around business domains. And last but not least, that's usually the selling point. This is how you sell it to the management. You can parallelize development, right? So software eats the world. We are building tons of software each day, so we need to parallelize this stuff. And microservices are usually one of the ways to do this. So why do I tell you all this stuff, right? Why do I tell you all this stuff? We are here at the micro-frontend talk, not about a microservice talk. I guess most of you already know the concepts of microservices. But why do you think this is important? Okay, I will show you. Oh, a little bit mixed up the slides. I will show you, because if we take a look again at the blueprint architecture here, at this blueprint architecture, we will find out that most of the advantages we got from microservices are actually lost again on the front-end side, right? If we take a look at this picture, we will find out that we are really not fully able to independent deploy, because we can deploy our front-end just at once. We can deploy it or we cannot deploy it. Of course, we can work with feature toggles, we can work with A/B deployments, but usually it's very cumbersome. We can deploy our front-end or we cannot deploy it, binary, right? The second thing is that we do not have real distinct operations. So we have one application. If this fails, the application will usually be down. So we don't have this resilience which we like to have in microservice architectures on our front-end world yet. And I'm working on the front-end side now for a couple of years, actually. I have a huge background with Java on the back-end side, and somehow I moved to the front-end. Well, I also don't know how this could happen, yeah. But actually, it turns out that I also like it somehow, yeah. And I can tell you that even if you work very long with languages like JavaScript or TypeScript, right, the rate of making mistakes is amazingly higher than it is in compiled languages like Java or C#, right? Because we just don't have this perfect tooling we know from the Java world. We just don't have it yet. I mean, we're on the way there, I would say, but distinct operations would be very, very important in such a volatile environment like the web platform, right? Another thing is technology agnostic. I was at the NG conference, I think in 2014. It was one of my first Angular conferences I ever went to, and I was very actually hoping for good talks, and there was this keynote from two people from the Angular core team, and I was really looking forward to this keynote. And what those two Angular people actually said on the stage, they came to the stage, said, "Hey, hello, welcome, I hope you like it so far, but, you know, we are building AngularJS, but we actually cannot really update it anymore. We will remove it, we'll replace it with something totally new, and we'll call it Angular." And I was sitting there and said, oh my God, fuck. What should I tell to my clients if I come back and say, hey, we are building now huge applications with AngularJS, but Google starts to stop maintaining this more or less, right, and builds a totally new framework. And at this point in time, it was clear that it would have been useful if we have a little bit of the possibility to be technology agnostic also on the front-end side. To have this possibility to work between different frameworks on one application. I mean, we're going in this direction with web components. We have at least the possibility to share components between frameworks, but we are still not there as it should be, in my opinion. Right? Another thing is small interface surfaces, okay? Monolithic application, usually we don't have them. I don't say that we cannot structure monoliths, fine, but of course, usually if the application sprawls, if it gets bigger, this gets harder and harder. Parallel development, and this is usually where people come to me and say, hey, David, we need your help, or we need the help from your company, please help us in scaling up our front-end development. Because those applications usually work if you have teams of 5 to 6 to 7, maybe 8 people working on one big Angular React application, one big code base, but at some point in time you cannot parallelize this anymore, right? At some point in time you can put more people into it, but it will not get faster. It's just over, right? You cannot scale a monolith forever. It will just stop at some point in time, and this is usually where people see the pain. This is where people say, okay, cool, we need to find something else. And this is what people tend to call fronted monoliths, right? And what do we do with monoliths? We kill it with something that starts with micro, and in our case we kill it with micro frontends. And the idea of micro frontends is just say, okay, let's split this. Let's split it in two. Let's build one, instead of one big single page application, two smaller single page applications, right? And this is usually where the talks about micro frontends end. They say just split it, build smaller frontends, we're done, yeah? But of course there's one important question we need to ask ourselves here: how do we do the split? Any ideas how to do the split? Well, the first approach, of course, would be to say, okay, you know what? We slice our whole code base from end to end. So I always use the Amazon domain. Actually, I never worked in the shopping domain, but I always use it because I think everybody's familiar with it. It's not too complex, so everybody can understand it. But let's say we have a catalog, we have an ordering, and we have a profile. So the catalog is where you find the products, the ordering is where you can order the products, and your profile is where you see a user picture, where you can edit your details. And then we say, okay, we built this system that is fully verticalized, right? That we have a catalog with a catalog microservice with your own catalog DB. And this turns out to be really nice, and we integrate all this just by good old hyperlinks. Okay? This is what we tend to call the hyperlink integrated approach. If we take a look at the 6 points again, we now have independent deployments. We now have distinct operations, so if the profile breaks, the ordering will hopefully still work, or usually still work. We can be technology agnostic. So we can build a catalog in React, we can build the Angular, the ordering in Angular, and we can build the profile, I don't know, in the framework of the month, yeah? We have small interface services, so we just have hyperlinks. It's not possible to be smaller in the integration between those systems. We can model around business domains, and we support parallel development. So this looks actually perfect. Yeah? So, and I'm done after 15 minutes with this talk, yeah? But everybody who is more than 24 hours in software development, I already used this phrase, knows that actually this idea is based on fully verticalized systems, and it's usually not possible to build fully verticalized systems. And what you usually have is you have something like this. You have dependencies between those services. And a good example for those dependencies is, of course, the dashboard. So let's say we integrate a dashboard in our system. Yeah? And the dashboard usually wants to show the latest products from the catalog. It wants to show the latest orderings, and it wants to show some profile information. And if we do this, we have two main problems in this approach. We have overfetching. So overfetching means that we fetch more data than we need. For example, we have a very generic profile microservice, which provides us a profile with 40 fields. In our dashboard, we need the first and the second name. So we fetch 40 fields, use 2 of them, so 38 of them are uselessly fetched. That's what we tend to call overfetching. Even bigger, over-requesting. This is where people usually start to blame REST for it, yeah? That you need to make a lot of requests to actually get the data you need. So you need to fetch the latest orderings. Based on these ordering IDs, you need to fetch products. Based on this product, you need to fetch product details to show a list of product details on your dashboard. But also there's a solution for this, and I think there's a very good solution for this. Again, from Sam Newman, who already did a lot of work in the area of microservices, he introduced something which he tended to call backend for frontends. Who knows the backend for frontend pattern? Okay, quite a few, cool. And the backend for frontend pattern actually exactly solves this. It's nothing else than an aggregation layer on the backend, which provides a very consumer-driven API for the frontend. So usually we build those microservices very generic. So we will build them for reuse. We build very generic APIs. As I mentioned, the profile service provides a profile. Doesn't matter who is the consumer of the profile, but it should be a very generic domain-driven profile. But our dashboard turns out to need a total different profile. So we build a backend for frontend in between, which translates the generic APIs into the very consumer-driven APIs. And one thing, because we work a lot with this pattern, which I always want to stress here because I think it's so important. If we think about software engineering in general from a very abstract view, I know this is super abstract now, but we have actually 4 layers, right? We have kind of persistence layer, we have a domain logic layer where we, based on the birth date, calculate if somebody is allowed to order something. We have a process flow layer where we say, okay, you're allowed to go here, after this you go here, and then you go here, and if this happens, you go here. And then we have some kind of presentation layer where we shape our data structures in a way that we can render it actually on the front end. And I think it's fundamental to understand, if you go for a BFF pattern approach, that the backend for frontend actually should only contain the presentation layer. If you put more than the presentation logic into this layer, you will end up again in a lot of duplication between your microservices. If you start to put in process flow logic into this, you will not be able to reuse it because the backend for frontend is part of the frontend. It's the deployment unit of the frontend. You will always deploy the frontend and the BFF together. It's one thing. It's just running on different platforms, but it's one thing. And if we start to put, for example, persistence into our BFF, and if we need this persistence on other frontends, we will have a big issue there. We'll build again those totally big silos. What we usually tend to use when we go for backend for frontend approaches these days, we use something which is called GraphQL. First of all, I think it's a nice technology. And second, it allows us actually to avoid this issue. It's very hard to do something else than presentation in GraphQL. That's why we usually tend to use it there, because it restricts us in really following this idea of putting logic, also flow logic, in the microservices and just the presentation logic in the BFFs. And I like this idea. I like this idea of hyperlink integration, because I think it's very important to understand that the more coarse-grained you can go, the more coarse-grained you should go. I think that's one of the fundamental understandings you have to know if you build microservices or if you build microfrontends. Think big. Yeah? That's one rule I can give you at least. But, and there's always a but. And if you hear but, you know, okay, you can forget whatever you heard now, because there's now a but. And of course, there's a but in hyperlink integration. It's somehow obvious if we talk about application frameworks like React or Angular. A hyperlink integration breaks your single page application, of course, because you always need to go back to the server, have this whole round trip, and this is usually what we don't want to have in single page applications. And one good example for hyperlink integration, in my opinion, is Amazon. So if you go to Amazon, search for a product and order it, and if you really take a careful look at it, you will find out that you go from the first page to the finished ordering through 7 different applications. A total 7 different applications. They run on total different subdomains, and they actually even look totally different. So you can see here, this is the ordering page, this is the product search page, and they just share the same logger, in my opinion. Yeah, not always even, but they look totally different. And that's okay for Amazon, because they say, okay, we want to independently deploy them, we want to build them fully independent, we want to have independent teams that work on them. And we, of course, take this drawback that the consistency is not given anymore. But there's a second problem I usually see with this hyperlink integration, or these fully verticalized systems. With this backend for frontend integration layer, we get back a horizontal layer. And if we think back to the days where we started to build microservices, we did this mainly because we wanted to get away from horizontal layers, because those horizontal layers have a big drawback. If you change something here, you will need to change it here, and you need to change it here. And this is what we tended to call the ripple effect. And with this kind of horizontal aggregation layers, we get this somehow back. So if we want to change something here, you're not independent anymore, because the change affects multiple applications. So let's take a step back. Yeah, let's think how could this be maybe different, and let's be a little bit creative and say, okay, we have a dashboard microservice, and this dashboard microservice provides a dashboard. And then we have a profile microservice, and this profile microservice provides a profile, right? And then we have a catalog microservice, this provides a catalog. and we have an ordering microservice that provides an ordering. And this is usually what I mean when I talk about microfrontends. I don't mean hyperlink integrated applications. As mentioned, I don't care about the term, just to understand what people usually mean when they talk about this. Yeah? So I think there are two different flavors of microfrontends. The one is just smaller applications linked together, and the other one is really multiple frontends on one page. So let's dig a little bit into the second flavor. Let's take a look at this one. And of course, there's again a very important question: how do we integrate those things? How do we integrate multiple microfrontends on one page? Give you a little bit of a break because now comes the most complex slide I ever did so far, I think. But give it a second. I hope it's useful. So if we think very abstract about this, we tend to have multiple layers. We have a repository, we have a build, we have a server, and we have a browser. Okay? And the first approach would be that we say, okay, we have each of our microfrontends in our own repository, and during build time, we merge this all together, deploy it at once, and if the client goes to our application, he gets the fully aggregated application already. A second idea would be that we say, okay, we have different repositories, we deploy them independently, but once the client hits our edge service, we start to integrate them together. So actually on the server side, we do the integration of those microfrontends to one page. And of course, the last approach would be that we say, okay, we have them in different repositories, we build them fully independently, we deploy them fully independently. The server returns them fully independently, and we do the aggregation on the front-end layer. So we will go through all of these three now, and we'll try to explain what are the advantages and what are the disadvantages. So build-time integration. That's, I think, the most simple one to understand. So we have, as mentioned, different repositories. We aggregate them all together at build time. And usually we do this with a concept which we tend to call monorepos. Who knows monorepos? Just a few. Actually, it's a very old concept. If you take a look at huge code bases like Mozilla's Firefox, it's based on a monorepo. And one of the ideas of monorepos is to simplify actually dependency management. To simplify dependency management and allow extensive sharing of code. And the interesting thing about monorepos, if you take a look at this, is that you usually have one file where you define your dependencies. You put all your projects in one repository. They are still totally independent projects, but you have one file where you define what are the dependencies of those projects. So you have one file where you define, okay, we're using Angular 8 now. And if you migrate to Angular 9 next month, you have to migrate all the applications to Angular 9 because you just have one place where you can define the dependencies. And we do this because there's a precondition to allow extensive code reusage. Because just then we can be sure that we can reuse the button in all our applications. Because this button is based on Angular 8, all our applications are based on Angular 8, we will not have any issues there. And there are lots of great tools to support us in doing this. One of them is NRVL. So it was actually, back in the days, more or less a very Angular-centric tool. Now you can build technology-agnostic monorepos. So you can build monorepos which contains React application, Angular applications, Express.js applications for your backend for frontends, or Nest applications for the same purpose. And another way would be, of course, a more Angular-driven approach, which is tend to be called Angular Workspace. So this comes for free. Since Angular 6, we have the support for Angular Workspaces in the Angular framework, which exactly solves this issue of doing monorepos. So if you take a look at build time integration and take a look again at those 6 points. So at least at the end of this presentation, you will know the advantages of microservices because you see the 6 points all the time. But in this case, we do not have independent deployments because we do the whole integration at build time, deploy it as a single thing, and then ship it. Yeah. So we don't have this advantage of independent deployments. We do not really have distinct operations because when it's shipped, it's already one thing. So it's a monolithic deployment. It's at the end, you could say, a monolithic application. we cannot really be technology agnostic. As mentioned, of course, there are ways. We talk a little bit later about these new standards which we could use for doing this, but usually we are not. But we have small interface services because we build fully distinct applications, sorry. And for example, tools like NRL support us in doing this. They support us in saying, okay, we are not allowed to have dependencies in our monorepo between these applications. Another thing, of course, we can model around business domains and we can parallelize development. That's the most important thing here. And this is usually where I start to change the things, where I say, okay, let's split our application into really independent applications. Let's integrate it together at build time and let's ship it once. Because the main issue, as mentioned earlier, is usually the parallelization of development. And build time integration solves this issue already. But then there are always those people say, okay, build time integration, that's lame, right? It's the simplest way, build time integration, we still have a monolith. But I think that's totally wrong. I think build time integration actually is the new cool kid on block, sorry. Anybody ever heard how the New York Times architecture looks like? The architecture of the world famous newspaper New York Times? Okay, I will tell you. So the business of New York Times is articles, right? They write articles all day long. Very boring actually. Just writing articles, publishing them. And what they do, once they wrote an article, so once they write a new article, they rebuild their whole application. They rebuild their whole application when a new article is written. And then they translate each article to a fully static article page. And this is what they do. So they don't have any server. They can just put this on a S3 bucket actually, because they don't need this notion. Sorry. Oh, there's animation wrong. They don't need this notion of servers because they just have it finished after build time. And this is a very good example for how they do build time integration and how they can fully scale their application, how they are perfectly, of course, when it comes to search engine optimization, and how it's super secure, because if you just have static files, there's no security leaks usually, besides classicals like cross-site scripting, but there's no administration console. You cannot hack a server here because it's just statical files. Other examples would be here the Smashing magazine. Okay. The Smashing magazine. Okay. Something is broken here. Sorry. Actually, the Smashing magazine or the Wise magazine do this in a very similar way. Frameworks we have here from a React world, we have Gatsby. In Angular, they're building something which is called Angular Photon. So they also want to go in this direction to support better build time integration, because currently Angular only supports server-side integration and client-side integration. But there are tools on the way to support this better. Okay, let's take a look again at it, and we see we have still, of course, some drawbacks, but it's the simplest and most easy approach to start. But let's go on to the next one, server-side integration. And for server-side integration, there's, I think, in particular, one framework most of you maybe already heard of and most of you already know. It's called Project Mosaic, and the library in this Project Mosaic is called Taylor from Zalando. Who knows this? Okay, just a few. Okay, I will roughly explain you how it works. Because at the heart of Project Taylor, there's still a very old concept, which is called server-side includes or edge-side includes. So this is existing already since years. And what you can actually do is you can define includes on your server. So that's pretty simple. So you say, okay, I include the products, the payments, the dashboard, and the shipping widget on my application. And when the Nginx, for example, gets a request, he includes all these widgets there and serves one application. This is server-side includes. And there are companies which are using this. One of them is, for example, IKEA. So if you go to the IKEA page, they build micro frontends, but they all include them together on the server side by classical old server-side includes. This comes, in my opinion, with two drawbacks. The first one is that JavaScript and CSS is globally scoped. This could be an issue if you integrate it all on the server and you just have global scoped languages. And the second one is that, of course, round trips are needed again. So let's take a look at how Taylor does this. As mentioned, Taylor is just building up on those technologies, but making them a little bit more modern or easier to use, I would say. So Taylor tends to call itself a layout service. So if a request hits the edge service, it actually hits Taylor. And based on the route, Taylor tries to find a template which it can match on those routes. And then it goes to the different layouts and it says, okay, this is the dashboard. And based on the dashboard, I need to show those fragments. And those fragments actually are requests to other microservices, and those microservices provide this view. So the view is really provided by the microservices, not provided on a different place. The microservices provide the view, and Taylor is just a layout service which integrates those views, those widgets together into one page. And if we take a look at the fragments, we have a couple of nice features here. For example, we can say primary here on the catalog fragment. And primary means that the HTTP code, for example, which is returned by this fragment will be used for the page. So if we go to a catalog and if we search for a product and the product is not existing, we get a 404. So the whole page will return a 404. Another thing is the async keyword, where we say, okay, we return it and fetch it asynchronously later because maybe the profile service is very small or the account service in this scenario. And then we also have a fallback source where we say, okay, if this microservice is not available right now, we go to maybe some static file on the S3 bucket where we just return profile service is not available, but the page can be fully rendered, and it provides us a resilient experience here. And then, of course, you have different templates for different routes. And Taylor supports JavaScript isolation. Actually, they do this very simple by a very old concept, what we usually very often see in the JavaScript world. So a fragment contains an HTML, a script, and a style. And they do this isolation by just wrapping this script and giving the script the DOM node, so it can only access the DOM node it gets from the outside. So at this point in time, you can avoid that you manipulate different things in the DOM which are part of your fragment. But the Taylor team usually says that this is not a way how you want to abstract away frameworks. You don't want to isolate frameworks. So the idea is not usually that you isolate whole frameworks like React or Angular. So in Taylor, usually you have those frameworks in the template here. And then those fragments can ensure that the framework is existent once they are loaded. Another possibility or another problem we raised earlier was CSS. So who thinks that CSS is isolatable? Nobody? Okay. That makes me sad because I think CSS is one of the most underestimated languages, honestly. Yeah. CSS was, in my opinion, never the problem to isolate. We can isolate CSS since years. There are techniques to do this. So there was first BAM, which is more or less a naming convention, which allows us to isolate CSS. It was a little bit cumbersome, but it allowed us this already a couple of years ago. Then we have something which we tend to call style components, where we just put the CSS into the JavaScript to make it isolated. Another thing is CSS modules, where we can just add hashes to our classes to ensure that they are unique, so we don't have those name clashes anymore. And of course, there are web components which support CSS isolation by default. So Taylor tends to solve those two issues of global scoped CSS and JavaScript in a very, very nice way. So let's go back to the advantages. We have independent deployments now, because we can build our applications independently and can deploy them independently. They are integrated on the server side, as mentioned. We support distinct operations, and we saw this very good by the fallback source in the Taylor template. So if one microservice is not available, this will not break our application. So we have resilient frontends if we go with server-side integration, and of course if we do it correctly. We can be technology agnostic. As mentioned, turns out which framework you want to use, but there are frameworks that also support you building fragments in different frameworks. We have a small interface surface, we support modeling out business domains, and we support parallelization of the development. So this looks nice, yeah? I will come back to this later. Let's go to the last approach, which is runtime integration. And runtime integration is usually made in a way that you have some kind of aggregation UI, where you do the routing, and based on this routing, you provide templates. So the idea is actually quite similar to server-side integration. So based on the route, you map to templates, and those templates load micro frontends from the backend services and show them or integrate them together on the client. And we tended to do this with iframes. Okay. Nobody likes iframes, and I can understand it, but iframes are still the most robust way to isolate applications on the web stack. And these days we usually tend to do this, as mentioned, with web components. A very popular, I wouldn't say popular, but at least well-known framework in this area is single SPR, sorry. But there are a lot of other frameworks which actually provide us this application or this aggregation UI, where we can then integrate different fragments from different micro frontends. So the aggregation is done on a single point at runtime integration. And there's a very interesting idea of saying, okay, if the integration is done on a single point or the aggregation is done on a single point, how about the configuration? Could we not also do the configuration on a single point? So who knows immutable web apps? Nobody. Really? That's interesting. So everybody will learn something. That's good. Who knows 12-factor apps from the microservice architecture? Exactly. Okay, a couple of more hands going up. So 12-factor apps is actually a guideline of 12 rules which you should follow if you build microservices. So for example, you should configure your microservice based on environment variables. So they are configured based on the environment where they run. They should not bring the configuration of their environment on their own. And this idea of these 12-factor applications is actually what people from immutable web apps used to bring it to front-end applications. And one idea, as mentioned with these environment variables, we can see this here very nice. We say here we have a script which exposes a global variable which is called env and provides us here the endpoints for APIs and gateways. We see on the top, or so below, we have all the includes from different front-end applications, and this allows us to do our configuration on a single point, and this single point is the aggregation UI. So if we want, for example, to do A/B testing, all you need to do is you need to take a second index HTML, give it different versions in the dependencies, give it maybe different configurations, and you can do this on one point. And I think that's a very interesting concept to follow, and at least to be aware that this exists also in the front-end world. Okay? Runtime integration. One more time, one last time. Let's go through the 6 steps. Of course, we have independent deployments. Of course, we have distinct operations. Because if one application breaks, it will not break all our applications. We can be technology agnostic. We support small interface surfaces. We can model around business domains, and we support parallel development. So this looks actually quite similar to what we saw when we did server-side integration. So which one to use, which one to choose? Any preferences in the audience? Who prefers server-side integration? Okay, who prefers runtime integration? Okay. Some people prefer nothing. Who prefers cats? Who prefers dogs? Okay, it's the same ratio of people moving their hands up. Okay, let's take a look again at it. So we have server-side integration, runtime integration. The big difference between those two approaches is that with server-side integration, we have this good old request response model. We did this for years, actually, right? If we take a look at the big frameworks like Spring MVC, GSF, ASP.NET, whatever, yeah, this was all request response models. So you did a request, got back a few. The advantage of those request response models is that they are very stateless, because HTTP by itself is stateless. And this is very familiar to us. This allows us actually to scale our applications quite good, because they are usually, with this request response model, stateless, at least on the front-end side. So the integration between our systems is done on the back-end side. Because we do the integration on the server, so we also do the communication between those microservices on the back-end side. If we go for runtime integration, we have long-living applications. So I always say to people, if they ask me if I could complain them, or actually back then when they asked me to explain them, the concept of single-page applications in very simple words, I said we're just doing fat clients in the browser. That's what we actually do. So we have very long-living applications, and we move back the state to our front-end applications. So we don't have this stateless request-response models anymore, but we have a lot of state in our front-end. And it turns out that the integration between those different front-ends needs to happen then usually on the client, of course, because you want to avoid these round trips again. So you need to do the integration on the client. And this is, of course, an example if you build very long-living application, but it comes with a lot of complexity in the front-end. If we take a look at what is used by companies, as mentioned, I work mainly with German clients. That's why there are mainly only German companies on the slides. But for example, the request response model is used, as mentioned, by IKEA. Zalando does it, and also the Rewe Group does it a lot. If we take a look at long-living applications, we see this is Deutsche Bank, Spotify, or Adessen. And I think this shows it very good what is actually the purpose of those applications. On the right-hand side, you have very reactive, very, I would say, modern, fluent applications. On the left-hand side, you have applications that need to scale very good. And I think this is actually at least one driving point what you need to decide. Yeah? Do you want to have very nice, reactive, fluent, single-page applications, or do we want to have applications that scale very good, where the integration is handled on the back-end systems and which avoids a lot of complexity on the front-end side? Okay? Cool. Anything that can go wrong? What do you think? If I need to explain you everything that could go wrong, I would need another 2 slots, yeah? Because there's so much that can go wrong, yeah? And as mentioned, I'm here for the rest of the day, so if you want to hear all the horror stories, what can go wrong, feel free to reach out for me. But I can give you at least an overview of the problems you have. UI and UX consistency is, of course, a big topic in micro frontends. That's the main problem usually. If you split your applications into smaller chunks, it's of course hard to be consistent between those smaller chunks. In a microservice world, we usually don't have this issue so much because we want to have less dependencies between those applications. But in a front-end world, even if you build high sophisticated stuff today in the front-end, we still have a huge layer which is just UI visualization logic. And usually one customer wants one experience from our company. So of course we need to have a lot of shared UI stuff between those micro frontends. And this is of course the problem we have there, why it's not so easy to cut these applications into really smaller chunks. And this is, for example, also a reason why monorepos are so successful on the front-end world, because you need to share so much between those applications. Yeah? You don't have this demand so much on a microservice layer. You usually just want to share some kind of common logging or exception handling libraries. But on the front end side, you need to share a lot because you need to want to have this UI and UX consistency. Another problem is shared state. So as mentioned before, especially if you do runtime integration, you will have a lot of shared state between those applications. There are people who build meta Redux stores, so that the Redux store on top of the Redux store. What we usually tend to do is we do the client caching, so we cache at least the requests from all our applications on a central layer in the front end, because it turns out that most of the shared state is actually on API request level. And the second thing which worked for us very good is that we expose immutable observables, so just in stream of events which each microservice exposes to the outside world. Other microservices can subscribe to it. And that is at least a smaller way of coupling those micro frontends together. Other people use, of course, event buses and stuff like this in the front end. So especially when you do runtime integration, you will have a lot of shared state, but also on the server side, of course. Resilience. Still a big thing, yeah. We still need to be aware that JavaScript has actually drawbacks. It's a very global-centric design language. Another one is tracing and analytics, which is very hard if you build so small fragments which can be deployed and run totally independent. Offline first, it's a huge topic, yeah. In my opinion, not really possible if you want to go offline first, that you build a micro front-end architecture and lots of more things as mentioned. Yeah, if you're really interested, feel free to ask me. We have a lot of experience in these things, but there's a lot of complexity you need to be aware of. Yeah. So we saw 4 approaches today. We saw Hyperlink integration, we saw build-time integration, we saw server-side integration, and we saw runtime integration. And now I usually also do this presentation at clients, and they always ask me, okay, David, what to choose now, right? What I usually do is I recommend them my favorite book. And it's really true, and it's not a joke. Of course, it's a joke, but there's a truth in this joke, and it really depends. And now comes the most important message of this presentation. Yeah, as mentioned, we have different approaches, but it depends, and it's not a black or white decision. What you need to do with these different approaches, if you want to build successful micro frontends, is you need to mix and match them. Yeah? So let's say we have again this shopping domain. We have a landing application. We have a shopping domain and we have this ordering domain. So we could already slice this application on a very coarse-grained layer and say, okay, we just integrate those applications by hyperlinks. But maybe the shopping domain is still too big. But we want to have a very fluent experience for our users on the shopping domain, and we go for runtime integration there. So we build different smaller micro frontends, aggregate them together with an aggregation UI, and also can split our shopping experience in smaller chunks. And for ordering, maybe it's fully okay if we have a lot of round trips because the user already decided to order, but we want to have very solid, and of course we want to have very less state sharing between those micro frontends, and we go for server-side integration there. And I think this is very important to really understand. It's not going for one thing in your whole application. It's really mixing and matching the different opportunities you have there. And I mentioned in the beginning that I'm in the mood of telling you secrets. Yeah? Here's the final secret. And it's, I think, a very obvious one, but it's a very important to understand. If you build micro frontends, you're building distributed systems. Okay? You're building distributed systems on the front end. And who knows the one and only valid definition of distributed systems? Everything that can go wrong will go wrong, right? And this is also true if you build micro frontends. As I mentioned before, yeah, there's a lot of things that can go wrong. And distributed systems bring a lot of complexity into your architecture. Yeah? And they also bring this in the front-end world. So if you build micro frontends, you build distributed systems. So maybe start with a monolithic first approach. Thank you very much. My name is David Leitner. I hope this was useful. I think we're out of time, at least this timer says me this. So as mentioned, if you have any questions, feel free to come to me.